Hey, so here we have this question number 10, which says a ball of mass m is moving over a fixed smooth track as shown. So we are given here the smooth track. The velocity of ball at point A is u. So here we are given the velocity as u and here the velocity is v. If HA and HB are the heights of the point A and B respectively above the ground, so we are given the height of point A as HA, height of point B as HB. We need to find out which of the following is the correct option. Now see here, when this ball will roll down this plane or when it will move on this plane, it is being acted upon by the gravitational force and hence its speed will keep on increasing as it will roll down this plane. Okay, and greater this height, greater is going to be the velocity here at point B. Okay, so from here we can see that if HA is greater than HB, then this velocity V that is at point B is going to be more than the velocity at point A. Okay, so out of these four options, which option is the correct option? Whatsoever we have discussed so far, from there we can conclude that option number 3 is the correct option and hence I can put it into a separate box like this. So I hope this question is again quite clear to you. Moving on to the next question for the discussion. So here we have the next question on the board, which is a pretty simple question from human eye and the colorful word. This says a person needs a lens of minus 2.5 diopter for correcting his distant vision. So here see carefully students, this is minus 2.5 diopter. Clearly from here you can see this negative sign indicates that the person is using which lens? A diverging lens, that is a concave lens, to correct his vision. And also as he is using this diverging lens, so it means the person is suffering from myopia, that is he is not able to see the distant objects clearly. Now here we are given few statements, so let's read the statements to get more clarification about the question. So here we have the first statement which says the magnitude of focal length of lens required for correcting his distant vision is 40 centimeter. Well, we can pretty find it out. Power is 100 upon focal length. If the focal length is given to us in centimeter in the case of myopic person, so this F is going to be 100 upon minus 2.5. So F will simply come out to be minus 40 centimeter. Again negative sign is showing that it is a concave lens. Okay, so the magnitude of the focal length of the lens, we have calculated it, that comes out to be 40 centimeter and hence this statement is correct. Now the statement 2 says the far point of person is 80 centimeter. No, we know in the case of myopia this focal length comes out to be equal to the far point of the myopic person. So the far point of the myopic person is 40 centimeter and not 80 centimeter and hence this statement is wrong. Statement 3 says the type of lens required to correct this defect is concave lens, which is again right. Statement 4 says the person is suffering from hypermetropia, which means this is wrong because the person is suffering from myopia. So it means out of these four statements only first and third is correct. So if we have a look at the options, option number 1 says only statements 1 and 3 are correct and hence this is the correct option for this question. I hope this question is again pretty clear to you. Now let's discuss the solution for the next question. Hey, so here we have this next question which says the ability of the normal human eye to focus on both near and distant objects by adjusting its focal length is called. We know this is power of accommodation and which option is the correct option? That is option number 2. So let's mark it. I hope this question is clear to you. Now let's move on to the solution for the next question.